Good morning, or indeed good afternoon, good evening, wherever in the world you might be joining us from today. Welcome to another PV Magazine webinar. I am Mark Hutchins, editor at PV Magazine here on this sunny morning in Berlin. And thanks a lot for joining. As always, we have a great looking show lined up for you over the next hour. Well, we are headed today once again into the world of PV manufacturing and the switch from P-type PERC to N-type technologies that has been gathering pace really throughout 2022. We are seeing a couple of different N-type products begin to roll off production lines in large numbers this year. And of course, the industry and those who buy modules and build PV systems in particular is eager to see how these modules and the often impressive performance claims that come with them will play out in the field. And we'll focus today on one N-type technology and one manufacturer indeed in particular. That is China's Huasun, which has launched its series of heterojunction modules and is targeting large-scale PV projects here in Europe and further afield. Coming up in just a moment, Wang Wenjing, Chief Technology Officer at Huasun, will treat us to a closer look at heterojunction and the technology behind its latest module series, including a look at the key points where it can outperform P-type PERC, that's passivated emitter rear cell modules that represent the bulk of the market today. And of course, that all-important question of silver consumption in heterojunction will be addressed as well. Wenjing, welcome.
Hello, everybody.
Well, after Wang Wenjing, we take a step away from the heterojunction technology itself, and we will hear from Matthew Jin, General Manager of Sales, also at Huasun, about the company's approach to the European market and how it is managing availability in what for many are times of scarcity for modules and many of the components and materials required to make them. Matthew, welcome. Great to have you with us today.
Hi, good morning. Hi everyone.
And finally today, following on from Matthew, as promised, we will take a look at the challenges and opportunities when it comes to integrating heterojunction modules into a full PV system. Jaba Barian, a PV innovation and design engineer at Belectric, is on hand to take us through the generation profile and a bit of the economics of a system built using HJT modules, with case studies and comparison both to N-type TopCon and P-type PERC. Welcome, Jaba. Great to have you with us this morning as well.
Hey, Mark. Thanks for having me. Good morning, everyone.
Okay, well, that's our three presenters, and that will be today's webinar. I will hand over, first of all, to our presenters from Huasun in just a moment. First up, though, a couple of housekeeping points from me. We are, of course, broadcasting live today, so please do send in your questions for all of today's speakers using the questions function on our webinar platform, Big Marker. I will be feeding your questions into the discussion after the presentations today. So please don't be shy, and we will try to get through as many of your questions as we can in our 1 hour slot for this program. One question I will quickly answer now is that yes, the recording and the slides from today's program will be available afterwards. These are emailed out to all who registered shortly after we wrap up today. And you can listen back to this webinar at your leisure at pv-magazine.com/webinars. Here, of course, you can also listen back to all of our past webinars and have a look at what we have coming up. Lots of great webinars on the way in the next few weeks, so please do check those out. For now, though, I will hand over to Wang Wenjing, Huasun's Chief Technology Officer. Over to you, please.
Is the HJT mass production in Huasun. My name is Wenjing Wang. As to the progress of a heterojunction solar cell in mass production, there's we so-called three generation. The first generation, it's a morpho-silicon thin film to passivated silicon wafer. This structure already go into the mass production last year. The average efficiency of this kind of solar cell is 24.3%, and the second generation of HJT is like middle of this. In the front side, we replaced, we used microcrystalline silicon or microcrystalline silicon dioxide used in the front side. This structure can let in more light into the silicon wafer, but for the backside, still a morpho-silicon thin film. This structure already go into the mass production this year, such as in Huasun, but it is still needs 1 or 2 years to make a mature. The third generation of this kind of solar cell is like a right hand. Not only in the front side is macrocrystalline silicon thin film, but the back side also the nanocrystalline or macrocrystalline silicon thin film. For this kind of structure, the efficiency can arrive 25.5%. In Huasun, there's a research of this kind of for different kind of technology. For last year, in the mass production already, we realized mass production generation heterojunction is 1.0. There's a 5 megawatt, but in the pilot line, we do the research on the generation 2. For this year, we installed 2 gigawatt HJT 2 generation. In the pilot line, we do the research in the generation 3. But in the end of this year or the next year, we will install another 4.5 gigawatt. The technology used generation 3. But in the pilot line, we do the research on another more advantage technology, such as copper plating or HPC. So for the first, we will take a look at the generation 1. How about the mass production situation? Right now in Huasun, this kind of technology already goes into the mass production. The average efficiency is about 24.3%, and yield is 98. There's also another many Chinese company to make this kind of heterojunction solar cell, but they report the efficiency is quite different. But the CTM is also a little bit different. But if we use the CTM, we use the CTM is equal to 100%. We calculate the equivalent efficiency from the module power. So we find out the equivalent efficiency is almost the same. It's around 23.9 to 24.1%. So as to the roadmap of the reduction, reduced of cost, so we can find the main cost, the high cost is the server consumption per piece. So at the very beginning in 2018, at that time when we use 5 busbar for M2 wafer, the server consumption for one piece is arrived to 350 milligram, and later to reduce to 250, and at 2020 when we use 5 busbar, 9 busbar for M6 wafer, to server consumption already arrived to reduce to 220 and 180. But for this year, this year we further used 12 busbar for M6 wafer. We further reduced the server consumption to 180, 150. And if we use another the technology such as SMBB, metal screen, maybe we further can decrease the efficiency, defer the server consumption to 120. And later, next step, if we use the server Cooper paste, maybe we can further reduce the server consumption to 180 or even 60 milligram per centimeter square. Accordingly, the server consumption per watt also reduce. And as about the HJT 2.0 and HJT 3.0, already there is some many company to do a lot of huge progress. Last year, there's many times the breakthrough the world record. At the written result is just this year, the June this year. The efficiency already arrived 26.5%. It's by the LONGi. Here is the curve, the ivory curve of LONGi. From the data of this kind of new technology, we can see the current increase very fast. The very recently, the LONGi's world record 26.5%. The JSC already arrived 41 milliamp per centimeter square. In Huasun, we do a lot of research from the November last year. It's just installed November last year already just installed a pilot line. From this pilot line, we can see the efficiency of our cell, our champion cell, increase very fast. Right now, already arrived 24.61%. And also, as to the module for the HJT3, they also can keep increase. For the M672 module, for PERC, for this kind of module, for PERC, the power is 450 watt. For HJT 010 is 475. For HJT 20, the power already can arrive 500. And for the HJT generation 2, we already installed a 2 gigawatt mass production line to use this kind of technology. But right now, we just beginning to running of this mass production line. It's a very beginning of the result is the best cell already arrived to 25.1%. And the best batch of the cell keep increase right now already 24 already arrived 24.5%. We will talk about the challenge of the HJT solar cell. The one problem is UV ID. We find out if we expose this kind of a solar cell on the UV light, such as 120 hours, the current the efficiency will drop about maybe 2.9%. So we do the experiment. We can see if the use new solar cell and expose to the UV light, there's the efficiency will drop down from near the 25% to near 24%. But if we use the light and temperature process, these efficiency can recover. This phenomena both in generation in the amorphous silicon HJT and the microcrystalline silicon HJT all have this kind of phenomena. We analyze the PR of this kind of solar cell before or after UV light. So we can see after UV 120 hours, the PR become dark. There are more black dots. That means there's more recombination. And at the same time, we find out the VOC will decrease. So if we make a module, the UV light can harm a lot of many layers, such as they can hurt the package film, they can hurt ITO, the doped microcrystalline layer, and even they can hurt the silicon wafer. So for the package film, we can use three kind of film, package film. One is high transparency film, and the second is a UV cutoff film. They can decrease the power of the module, and we can use the UV to visual light conversion film. It can increase the power. For this kind of the doped layer, not only amorpho and the macrocrystalline layer, they recently some other author to find there's an abnormal Stabler-Wronski effect. It's meaning if we use LETP, the efficiency can increase, but there is a dark degradation, the UVID, and annealing degradation. And for the interface of amorpho and the crystalline silicon, there is a Stabler-Wronski effect. It meaning there's a LID, but if we make annealing, it can recover. So what the solution of the UV light? It's a temporary solution because maybe we still cannot find the problem inside the cell. So people just right now want to use some encapsulation film to solve this problem temporarily. So there's some material can convert UV light to some other kind of other wavelength light, such as the blue light or red light. They can absorb the UV light that make fluorescent to change the wavelength to the blue light. So if we can use a different encapsulation film, this QE is quite different for the module. If we use the high transparency EPE, the QE is like this. But if we want to cut off the UV wavelengths, maybe it's become stable. But the QE in the short wavelengths will go down very fast. But if we use the UV to visual conversion film, they can convert these kind of short wavelengths to the longer wavelengths, so it can increase the current, increase the response of the the response, and can increase the current. So for this kind of a different kind of package film, there's an outdoor experiment. So we can find the UV VR film is quite good, and UV cutoff is also good. But high transparency film, the degradation, the power degradation is very serious. But indoor experiment is quite different. Such as we use the density of UV light is 180 watt per meter square. We can see For the UV cutoff film is quite stable, but for the high transparency film or UV to VR film reduce at first, and after a longer time, the high transparency film further reduce, but the UV to visual film become stable. But why this happen indoor experiment? So there's a report about this kind of UV visual recovery material. If you use different irradiation density and use a irradiation dose, we use to expose to the line for different time, we can see if we use the higher irradiation density, this material degradation go faster with the irradiation dose. So if the irradiation density becomes lower, it is quite stable. But for the outdoor, the UV light, the density of UV light is just like this, is 25 volt per meter square. So it's somewhere like here. So for the outdoor, this kind of material is quite stable. Oh, finally, come on to the summary of my talk. So right now we already realized the amorphous silicon HJT. The average efficiency is 23%, yield is 98%. Next step, from this year on, we will install the macrocrystalline film passivated the silicon wafer, this kind of a new HJT structure. We hope the average efficiency will arrive 25.3%. Okay, that's all. Thank you for everybody.
Thank you very much, Wang Wenjing. Great to have this level of detail on heterojunction technology today. Well, our audience are a little bit quiet so far, but please do keep your questions for Wenjing and for the other speakers coming. We'll save those, I guess, for the Q&A at the end. And right now, I will pass straight over to Matthew Jin, who will tell us a bit more about Huasun's market approach and well, getting these modules out there into the field. Matthew, are you with us?
So can you see my screen? My slide? Hello?
Hi, Matthew. Yeah, I think this is
okay. Okay.
You need to show your PowerPoint, Matthew. Yeah, in full screen. Thanks.
There we go. Got it.
Okay.
All right,
okay.
Matthew, over
so
to
my
you.
name is, hi everyone. My name is Matthew Jin. I'm the general manager of the Sales and Marketing Center in Huasun Company. So today my presentation is HJT portfolio and the supply in Europe. So first, I would like to make a simple introduction of our company. So Huasun is a new player in the solar energy. So we established in July 2020, and our focus on HJT solar cell and module manufacture. And we also specialize in HJT wafer manufacture. So for the present, we have 2.7 gigawatt in HJT solar cell manufacture, and also we have 2.7 gigawatt module manufacture. So all this based on N-type, and most of our HJT modules we are using double glass. So about our Huasun team, so we are the new player for the solar, but for our team, especially for our R&D team, the main team members all have more than 15 years experience in solar technology R&D, and we have more than 100 talents in HJT field, and 1 chief scientist and 2 leading talents in HJT field, 4 PhD and 33 masters. So for the HJT technology, the new generation, no matter for right now, compared with the PERC technology, the HJT have many advantages, but also for the future, HJT is a good platform, especially combined with the tandem cell technology, which can get much higher efficiency and a better cost compared with the present PERC technology. And so for the massive production advantage, especially on the efficiency, compared with the PERC, which is around 23%, the HJT cells start from 24%. So for Huasun team, our average efficiency in mass production is reaching 24.7%. And our target to reaching 25% around the end of this year, and 25.5% in 2023. So for the circular temperature coefficient, minus 0.26% per degree Celsius. So for example, for this performance, a 500 watt panels, if the environment temperature reaching 65 degree, compared with the mono PERC and HJT, the efficiency loss in hot climate from 18% to 15% and to 10%. So by this performance, the HJT can get average daily power generation increased by around 4%. It's extremely low attenuations. For the N-type wafer, there's no BO bond, resulting there's no LID effect. And the TCO film on the HJT is conductive, so the charge will not polarize on the surface, which can prevent the potential induced attenuation, avoiding PID from the structure. So we also use the EPE as the film, which has a stronger waterproof performance, and plus the double glass design, the PID attenuation can be prevented. So for the great weak light performance, you know that from the early morning, especially in the early morning and late in the afternoon, the weak light performance of the HJT compared with the P-type, it can generate more power, and which can contribute about 0.5 to 1%. And the bifaciality for the HJT, it has a better performance of the bifaciality. Compared with the regular bifacial PERC, the HJT has more than around up to 95% of the bifaciality performance. But for the regular PERC panels, it's around 7 to 8%. Based on this performance, there are some installation for the HJT, and especially for the high bifaciality panels installed by vertical installation structures. So this can increase the power generation, and it's also very good performance by using a tracker. So we have some project by using the HJT with the trackers, and the power generation hours can reach around 2,000 hours per year. So for the processing advantage, compared with the regular technology, HJT production process is quite simple, just 4 steps. But compared with the other technology, which is more than 10 steps. Based on this, so the cost, potential cost reduction will be more competitive compared with the regular technology. So for the ultra low carbon footprint, so based on the HJT higher efficiency, lower process temperature, by using thinner wafer and simple processing. So till the end of this year, Huasun can get around 397 grams per watt for the HJT module manufacturer. So this low carbon footprint is a very good value for by using the HJT technology and product, no matter in China and also in Europe. So for the materials of the modules, no matter for the low temperature co-efficiency, high bifacial energy yield, and better weak light performance, or no LRD, no PIDs in cells, and especially the lower life degradation rate. This gives the high power generation for the performance. And for the reliabilities, for Huasun, we are making the G12 cells by using half-cut wafer instead of using cutting the cell technology, which can reduce the power loss by cutting the cells. And also we use the EPE, which has a better waterproof. And also this year we are using a special sealing at the edge of the module, which prevents the water goes into the glass and the module. So which can increase the life and make the module more reliable. So for the real installation, we cooperate with some third party for some project for testing the generation performance. So in Hainan province, we cooperate with the CTC inspection group, and the module we are using 460 watt compared with the PERC panels, and by the white ground floors and the regular floors. So the HJT modules, the energy yield has more than 6% power generation. So for the technology upgrading, so for last year, when Huasun started the manufacture for the HJT cell, the first phase we manufacture M6 cells. Based on the 24.5% cell efficiency, our module can reach 475 watt. That's for the last year. So this year we start to manufacture the G12 cells, and the cell efficiency can go up to 25.2%. Based on this efficiency, the 132 cell half-cut solar module can reach 720 watt. So from this year to the next 3 to 5 years, every year the cells efficiency goes up. And in 2025, we have planning to make a tandem cell, which is combine the present HJT plus the perovskite. And based on this technology, we can reach 28%. And the same dimension of the panels, the power can go up to 800 watt. So some introduction of our Himalaya series modules. So for our G12 modules, we launched in the second quarter of this year. So we have 3 models based on the 3 dimension. So the panel power up to 710 watt. Based on this dimension modules, the main target for these modules are for the ground installation project. So we offer we offer 15 years product warranty and 30 years life for the performance warranty. So for the M6 cells, we also mainly offer 3 models. So for the 400 watt with 120 cells panels, we are mainly for distribution market. And for 144 and 156 cell modules, this also both can for commercial roofs or for ground installation project. So no matter for the G12 or M6 cell modules, the module efficiency we are doing is more than 20%. And for the M6 cells this year, based on the 144 cells panels, we reaching 500 watt, and the module efficiency goes up to 23%. So we are also offering black module to European market, which is very popular by using the smaller dimension modules, but the power and efficiency is quite higher than the regular PERC. So by using 400 watt 120 cell modules, especially the cell especially the module efficiency can reach 22%. We got a lot of customers buying these black modules. So for the future, next year we have planning to launch our M10 series modules. Based on this side cells, the module can reach 440 watt by using 108 cells. Based on this dimension, the regular PERC, the module power for single glass just 410 watt. So the same dimension of the module, but our panel is first is bifacial panels. The second is the power is more than 35 to 40 watt compared with the same dimension module by using PERC cells. So if we using the 442 cells, the module power will go up to 590 watt. But based on for the PERC, the most popular is just 550 watt, which is 40 watt less than the M10 cell HJT module. So for the warranty, compared with the regular PERC, which just provide 12 years product warranty, we offer 15 years product warranty and 30 years performance warranty. So the future, we planning to make more than 20 years warranty product. So for the choice of benefit to empower the world, we would like to introduce some introduction of compare with the PERC and HJT in the project ground installations. So here example for 100 watt installed in Hainan province where the temperature is high. So the baseline is based on 72 cell 100 M10 cell PERC panels, all bifacial panels. So we are using 700 watt compared with 440 watt PERC. So the LCOE will be around 6.6% less compared with the PERC panels. Based on this performance and the support, it gives a lot of support and also reduce a lot of cost for the EPC company and also the project investors. So some project we did in Europe and also in China. So here is the here is the project we did with the EPC company in Bulgaria. The project, the total planning is 350 megawatt, and we supply more than 200 megawatt already. And all the modules were sent to the EPC, and this project they are using the tracker with our bifacial modules and other modules with the same dimension, and which is between 460 to 475 watt panels. Here's another example of the project we did with in China, in Shandong province, the 40 megawatt. And the picture includes both the PERC and also HJT. So the power generation compared with the PERC is around is more than 6% compared with the PERC modules. Here is some roof installation of the HJT modules. Compared with the ground installation, the roof installation, the module temperature is higher than the ground installation modules. The better power co-efficiency brings a more power generation compared with the regular PERC panels. And here's another example for the roof installation for residential market. A 5 kilowatt project we did work with our distributor and some EPC company in Europe countries. And roughly introduce about our European market development. So we sent our HJT module to more than 17 European countries. In Bulgaria, that's for the project, their planning is more than 600 megawatt for the project cooperation. And in Swiss, we have partner and also distributors with the Swiss dollar. And in German, we have partners like PV Selected and other 2 major partners. And France with 1 major partner. Spain, we have a sales office, and there are over 1 gigawatt pipeline with our partner over there. And for the other countries, we also cooperate with different partners, and they are all over gigawatt in pipeline in the next year. So finally, the end to build a zero carbon world by using a better technology and a better product. Thank you.
Thank you, Matthew. Well, we are running a little short on time, so I will very quickly pass on to Jabba Berian from Belectric, who will have some more information about the system integration with these modules. Jabba, thank you very much for staying with us. Over to you.
Yeah, thanks. Hi, everyone. Welcome to my talk. So I'm Jabbar Barian from the Innovation System Design Department at Belectric. Without further ado, I'd like just to tell a bit about Belectric. Belectric started 2 decades ago as an EPC company, then in less than 10 years became a global leader in solar projects. So currently Belectric has more than 4.2 gigawatt peak installed capacity and more than 1.7 gigawatt peak of O&M. Regarding expertise, so Belectric has a range of various expertise in-house, starting from R&D through project development, EPC, as well as expertise in O&M. Regarding the agenda, I have a small or short agenda. I would like to start about solar cell type market overview, then talk a bit about the price competitiveness of heterojunction PV module to the mainstream P-type PERC, then take a case study about the project where we compare between heterojunction and P-type PERC in terms of profit. So here I would like to show the cell type market share. What we see here that there are different types on the market, so the P-type and N-type, and the microcrystalline P-type. These results are from the ITRPV 2022. What is important to see here is by 2022, we have 20% market share from the N-type, which is expected to grow over the time. So, but important to note, actually, the N-type market, so the N-type cell market share will be there several cell concepts, which I highlighted here: TOPCon, heterojunction PV modules, or heterojunction cells, and IBC. And the question which will actually dominate the market share by 2030, because by that 2030 we will have the N-type actually dominate the market over the P-type. So to answer this question, actually, I find it a bit difficult because if I look to these plots here, this is from Tying News. So they release every month the highest PV module efficiency from different PV module manufacturer, as well as different technologies. So this release was from June. What we see here important, I highlighted, is that the fact both technologies, so the heterojunction PV module and TOPCon, so from Julewood or heterojunction from Huasun, they can have the same efficiency and the same power, which already indicates actually there is quite a high race in terms of power and efficiency for these two cell concept in N-type. And the question is, which will lead the market for us? We see there are 2 factors, which are the volume and the price gap. So the volume means how many supplier will make the shift from the P-type PERC, which we see here on the right side, reaching the efficiency limit, either to TOPCon or heterojunction. And second factor is the price gap, which technology or cell concept, N-type cell concept, will be produced with the lowest cell gap, with lowest price gap to the P-type PERC. So talking about the price gap, I would like to discuss this in a project or in a case study here. What I have is a beneficial power plant in Denmark. So a project which we are working on recently. So we have a 25 megawatt peak on this project. After doing a system design optimization, it turns out actually a fixed south for P15 degree using bifacial modules with 3 meter row spacing and DC-AC ratio for 1.2 is the optimized configuration. And then for the sake of comparison, I used 3 bifacial modules with 3 technologies. So the P-type PERC, the N-type TOPCon, as well as the N-type heterojunction. In terms of LID, I used the 1.5% for a P-type, and then for N-type, I used 0.6%, even though some manufacturers guarantee 0%. So since it's a bifacial power plant, so the albedo would be 20%, assuming a grass area. So here, to find out what is the price competitiveness threshold for Huasun, I use this case assumptions, which you see here on top. And then I use the current pricing for the P-type PERC and N-type TOPCon. And then the question would be, what would be the price for heterojunction PV module from Huasun to be competitive to P-type PERC? So to find out this, I have the plot on the right side hand, which shows the beneficial system net present value over the lifetime of the project. And then here you can see the red line shows the P-type PERC net present value, and the blue line is N-type TOPCon net present value. So we can see it clearly here for this project, N-type is already competitive based on this pricing in comparison to P-type PERC. And then to find out actually what is the price threshold for Huasun or for the heterojunction PV module to be competitive, I calculated different net present values using the heterojunction PV modules. And this is shown in the line, so the black line. And then if we look to intersections now, we will see that, so in order that heterojunction PV module to be competitive to P-type PERC, the price should not be higher than 303 euro per kilowatt peak for this project. And then in order to be competitive to N-type heterojunction or to N-type TOPCon, the price should not be higher than 277. So this is in terms of absolute price. It makes more sense to talk about price gap. So in terms of price gap, it turns out that heterojunction PV module should not be expensive, or the price gap should not be higher than 49 euros per kilowatt peak when it's compared to P-type PERC. And then when it's compared to TOPCon, the price gap should not be higher than 12 euro per kilowatt peak. So now if I pick up the current price from the market, which is 284, and then I see here in the plot, there is a delta where it shows that for this project, actually based on this pricing, the heterojunction PV module, it's already profitable to the P-type PERC, but not yet to the N-type TOPCon. There is still a slight gap behind. So now you would ask a question, actually, what makes this technology for this project actually outperform the P-type PERC? For this, I first look to how the system design would change actually if we use a P-type technology or PERC technology and then using the new technology. For this, we run several or a lot of simulations using fixed tilt tracking east-west systems with different row spacing, different DC-AC ratios. So here, more than 5,000 simulations. It turns out actually what you see here in the table that the fixed south for P15 degree using beneficial modules are the same for both PV module technology. It means the system design did not change that much, changing the PV module technology, except the DC-AC ratio actually is a bit lower for the heterojunction PV module than the P-type PERC PV module. What is important to see here in terms of cash flow, so using heterojunction PV module as a reference, we see that actually the P-type PERC offer much lower capex and opex than the heterojunction PV module, but actually fails in terms of sales of electricity. So it's very behind the heterojunction PV module, which in the end makes the net present value difference heterojunction PV module much lower. Here it's around 575,000 euros. So it's already, so it shows clearly that the heterojunction PV module, based on this pricing, it's very, very profitable in comparison to a P-type PERC for this large-scale PV project. So what makes now the heterojunction superior to P-type? For this, actually, what I did in previous table is based on this equation, that the net present value is the difference between sales of electricity discounted over 30 years, and then the total expenditure also discounted over 30 years. And then the factors which actually PV module technology dependent, which goes in sales of electricity, are highlighted here on the left. So you have the yield, the installation, the installed capacity, and the PV module yearly degradation. So we'll see actually for this project we have how both PV module are compared. So in terms first of yield, we found out actually the heterojunction PV module for this project has higher yield, about 1.7% higher yield. And then if we'd ask question, what makes actually this yield higher for heterojunction, you would see here on right side hand the pie chart, which shows different factor contributing to the improved yield for heterojunction. So mainly you would see that the low light behavior and LID are the main contributors to higher yield. And then in second position comes the beneficiality due to the beneficial factors. So beneficial factor or the beneficiality of the PV module of heterojunction is higher than the P-type PERC. And then in third position, the temperature coefficient. So second factor we found out, actually what you see here on right side hand is the layout. And then if we use this layout with the P-type PERC module and then with heterojunction, we see there is a gain in installed capacity. So a gain of 1.1 megawatt peak more if you use heterojunction PV module, and this is thanks to the efficiency of heterojunction. And the last factor is the degradation, which is very important. What you see here is the degradation over time of the power plant for both PV module. So the P-type PERC on orange, and then the N-type heterojunction in blue. We see here important that in the first year degradation for the P-type is 2%, while for heterojunction is only 1%. And over the years, the P-type degrades faster than the N-type, which actually makes quite big difference. When the year it's 30, here you get 3% more for heterojunction PV module. So this degradation actually is very important because usually it's overlooked by investors. Usually they use the yield from PV cyst, where this degradation is not cannot be seen. But when we take the degradation over time, we will see actually the yield we see before becomes even. So the yield gap between heterojunction PV module and the P-type PERC PV module becomes bigger even over time, and then this has a big impact in net present value. So here, just to mention, actually, there are other factors which go in total expenditure, which I did not show here for the time, which also there is an advantage for heterojunction PV module, which are balance system costs. It's lower for heterojunction PV module, and also the price gap here is very, very important input, because this actually will have a big impact in net present value if it's different. So to come to conclusion, we have shown actually that the N-type heterojunction PV module, it's already competitive, but it's even very, very profitable to P-type PERC for large-scale PV project in Europe. And then we have shown also that heterojunction PV module comes with higher capex, opex, but potentially actually increase the net present value by several €100,000 when we consider the lifetime of the project. And then we have shown that actually several factors makes N-type heterojunction ahead to P-type, which are the yield, installed capacity, degradation, and the price gap. So last but not least, to ensure the profitability of the heterojunction PV module, actually reliability is equally important to be investigated and evaluated, which I did not show actually in this talk, just to gain some time. And this, I would like to thank you for your attention.
Thank you very much, Jauba Berian from Belectric. Great to have some insight into system integration with these new or new to mainstream manufacturing modules. Anyway, well, we will invite our other two speakers also for a brief Q&A. We are a little short on time. First, though, Jabba, one person in our audience noticed that in your case study, the DC to AC ratio was lower for the heterojunction than for PERC. Can you explain why that is?
Yeah, I think here actually makes here it highlights the fact that due to the higher yield or for this technology, high efficiency, so it makes sense actually to go with lower DC-AC ratio, means pay a bit higher in inverters, but actually don't compromise the yield. While for the lower efficiency technology, it's better to compromise actually the yield and pay less for the inverter. So this is actually exactly what we see here in this lower DC-AC ratio.
Okay, and one further question: which analysis tool did you use for the economic side on these projects?
What do you mean, which analysis in terms of case assumptions?
I think so. Yeah. I think that's
I
what
use the very current case assumptions for Europe. So in terms of PPA, so usually what we do is we use PPA for 10 years and then the second PPA for 20 years. And those PPAs actually we use them based on price curves, and also use discount factors, which I mentioned in the slide. So I would say this is the most updated one business case which we have for our market in Europe.
Okay. Thank you very much. Well, we'll go now a little more into the technology heterojunction questions. Please, if you can stick around for a few more minutes, though, Java.
Yeah.
So one question probably for Wang Wenjing first of all. I noticed that Huasun, you mentioned that you do for the half cells you do the cutting at the wafer stage and then make the cell already as a half cell. How does this affect sort of throughput and the economics in cell production?
You mean the film, the UV light?
Or that you are cutting the. I think you mentioned that you are cutting the wafer before making the cell. Is that right? I think most
we cutting the wafer. So we used the half a wafer, half a cell, half a wafer.
Okay, sure, but as I understand, most manufacturing they manufacture the full cell and then cut it afterwards.
Yeah. Right now, when we use a small cell such as M6 wafer, so we firstly we make a solar cell, and then to cut after the make a solar cell, we cut the wafer to two pieces, and we use the laser, and also at the same time when we cut the cell and put some cold water and to reduce the temperature, and here can reduce the hurt of the edge. But for the large wafer, such as for 120 wafer, so we cut at first for the wafer. After we make a half wafer, we make a solar cell. So after make a solar cell, it's not for larger wafer we not cut after we don't cut after solar cell baking.
Okay, thank you. I should mention before we go on, also joining us for the Q&A is Chris Jin, Director of International Sales at Huasun. My apologies for forgetting to introduce you earlier. Now, well, we're sticking though with the heterojunction manufacturing theme. Plenty more questions coming in from the audience on that. Is there obviously heterojunction cells are pretty temperature sensitive. Is there an annealing or a firing step in your manufacturing process? And what is the maximum temperature that's possible with that?
For our mass production, the after the when we after screen printing, and we would there's a temperature process. The highest temperature is around 200, maybe not so. It's 180 to 200, something around that. The process, the temperature process.
Okay, and this is quite close to the maximum that a heterojunction cell can be exposed to, right?
Mm-hmm.
Okay, and now I think you touched on, and Matthew as well touched on the extra bifaciality, or the improved bifaciality compared to PERC. How do you expect this to develop? Can you push the bifaciality even higher?
I answer this question, or the Matthew?
Sure. Well, you can. Yeah. Perhaps you start, Matthew. You can also feel free to jump in.
So,
Matthew, I'm sorry, I can't hear you at the moment.
Sorry. So I mean that how to increase the bifacial factor. You know that we have some potential customer. When they are talk to us, they are asking what's the maximum bifacial factor we can reach. Most of this customer, they are looking for the bifacial factor more than 90%. Some they want to guarantee that the panel can reach that. So we are offering some frameless panels. Without the frame, there's no shading to the backside of the module. Another, we will increase the space in the middle of the modules where we put the junction box, and also we will reduce the height of the junction box to make less shading to cover the cells in the middle. To increase the middle of the module, that is to prevent the gel, which will cover some backside of the module. So by doing this process to increase the bifaciality at least to 93%. between 93 to 95%.
So we can.
Mark, you were muted. Can you repeat, please?
Hi, Mark.
Can you hear me now? Yeah. Sorry, I'm just chatting away on mute. Sorry, I was asking what sort of time frame do you have for this improvement? When might we see sort of 95% bifaciality in production?
Actually, we are now offering the families with higher bifacial factor panels to the market. Some to Japan market and some to Germany market, and there are more people asking for such kind of panels. We are offering to them.
Okay. So this is already. Okay. Next up. Oh, quite a few in the audience are asking on the module side are asking about your lamination strategy. Is normal PoE or EVA sufficient, or do you have something extra? And do you also do edge sealing in glass?
So we generally use the EPE. There's a two EVA in the middle. In the two sides is EVA. EPE. EPE is a two side is a EVA, but in the middle it's a PoE.
Okay, that makes sense. And is that because PoE is slightly more expensive, or is there a technical advantage in using the two?
Mm-hmm. But the resistance of the water is high for the PoE, but the stick intensity for PoE is not so good as as EVA. So in the two side into the near to the wafer and the wind and the glass, and two side use a EVA to make a high intensity of stable stick on the, but in the middle use the PoE to have a high resistance of the water.
Okay. Well, we have already gone over our 1 hour slot. I will squeeze one or two more questions in though. Thank you to our audience for sticking around. Looks like most of you are still with us. And next up, I believe Matthew, you mentioned on the European side that Huasun has a partnership with EcoSoliver over in Hungary. Can you tell us a bit more about this? Is this are you manufacturing modules with them, or how does the partnership work?
So Chris, please have to answer this question.
Yeah, we have just like started the cooperation, and as you know that EcoSolify is the like currently very few the manufacturers of heterojunction technology in Europe that we are now working like closely to developing and also to using they have their own ability in Europe and to starting to expand it to project side, and also as well in the future they will also expand maybe to module manufacturing as well in Europe, which is quite like demanded in Europe recent 2 years, and that will be helping to build up more capacity in Europe as well for the module as well. So we are going to cooperate with each other for also supplying the cells to Europe to help them to build up the modules as well with heterojunction in Europe. And we also under discussion with each other for their potential technology like perovskite and tandem, such kind of potential cooperation as well in the future. So it's kind of we just started recently for such kind of cooperation. Yes.
Okay, thanks. Well, exciting times indeed. All these new technologies being investigated. We will have to wrap up very shortly. I will squeeze one final question in though. Now we've talked quite a bit in the last hour about comparing heterojunction to PERC technology. Of course, there's another N-type technology in TOPCon that quite a lot of manufacturers are going with, maybe instead of heterojunction. Have you been able to do a lot of comparison with between heterojunction and TOPCon, and how do these two compare to each other? Maybe
Okay. I speak first because yes, the TOPCon and heterojunction as well, also IBCs are like the major technology in N-type, and we will see much like bigger capacity in TOPCon compare with like capacities now in heterojunction, and the major like top players are moving to TOPCon. I think starting from this year with a bigger capacity. And yes, we are going to set up. We already did something just in Matthew's presentation. We had some comparison with TOPCon and also together with PERC. And recently, we also working with the third-party certificate company like TÜV for make a comprehensive compare with heterojunction, PERC, and TOPCon again by a third part, and with a much detailed comparisons that leads into a type of report as well.
Okay, so I have some additional comment about this question. For the HJT solar cell, so actually the technology developer of the roadmap of the silicon solar cell, they need the two sides also passivated the contact from not only in backside but also in front side. But for the TOPCon, for mass production, right now, only the backside passivated by the crystalline silicon film. But in the front side, it is the same, just the same as the PERC cell. So still there's a metal and semiconductor contact each other. So TOPCon only the half passivated, but for the heterojunction, not only the backside passivated the contact, but in the front side also contact. So the main advantage for the HJT from the TOPCon is it is high efficiency. The mainly the advantage is efficiency. Right now, for HJT, the efficiency can arrive, I think, for mass production, average efficiency can arrive over 25%. But I think for TOPCon, if we CTM, the CTM is equal 100%, the equal efficiency is something around 24%. So it's maybe, I think, 1% efficiency can get a huge difference between the HJT and the TOPCon. So that's main advantage of the HJT.
Yeah, I can comment.
Please do.
Yeah, I can comment from the solar project point of view. Yeah, we have been comparing both technologies actually, and the good thing they came actually in similar time, and what we see actually it's in terms of performance they are very similar. In terms of efficiency, talking about industrial PV module efficiency, we see them similar. We can get the same efficiency for both PV module. What we see important actually is that the degradation for heterojunction PV module it's lower, but this is what the PV module manufacturer guarantee. And this is something important because, as I mentioned before, the degradation plays a role. So the degradation of heterojunction PV module it's lower than N-type TOPCon. Another factor which is more important is the price gap. So we see that since both PV module they can have the same efficiency, they can have the same power. In the end, actually, which PV module will be produced cheaper in comparison to the PERC? And this is what we see now. And the only thing actually makes a change when we select system design. So it's usually the price gap or the degradation. Apart from this, is very similar performances.
Thank you very much, Java, for your insight there. And well, I think that is a great place to wrap up for today. Thanks once again to Wenjing, Matthew, and Java for your presentations today, and to the three of you and to Chris as well for joining for the Q&A. And thanks also to everyone behind the scenes at Huasun, at Belectric, and of course to my colleagues here at PV Magazine for working to put together a fantastic webinar for today. And of course, finally, thank you to all our viewers for joining today and to all who submitted a question. We really do value your contributions to the discussion, and my apologies that we can't get to all of the questions asked today. Also, that we've ran a little over our 1 hour slot for this webinar. Thanks for staying with us. Otherwise, the August edition of PV Magazine is out now, just published earlier this week, and this month our focus is very much on energy storage. Maybe a small step away from today's webinar's topic, but still something that should be of interest to all working in solar. We've gone pretty deep into the battery supply chain, looking at lithium extraction in Europe and other alternatives to lithium-ion, vanadium redox flow batteries in particular. And also on the operations side, an update on how storage is showing its worth and opening up space on the grid for more of those large-scale solar projects that we've talked about today. And we have a little break from webinars coming up now, but I will be back in a couple of weeks on August 30th and diving right back into the world of N-type technology with an in-depth look at the durability of N-type modules and how some of the claims being made there are backed up. And just after that, our excellent editor, Mario Maisch, will be again looking at new technology in the large-scale PV segment, this time investigating the effect of high-powered string inverters on system design. And those are not to be missed. Head over to pv-magazine.com/webinars to register free of charge today. For today's webinar, though, that is just about it. Once we end the broadcast in just a moment, there is a very short questionnaire that will pop up on your screen. Actually, it's in the left-hand corner now. That's just looking for some feedback on today's program, and we really do appreciate if viewers can take just a minute or so to fill that out. Your feedback is very valuable to us. So thank you in advance for that, and we hope to see you at another PV Magazine webinar very soon. For now, though, thank you one more time to our speakers, and that's goodbye from all of us.